Now let's take a look at some examples when we're looking for higher ordered roots now. So number one, we're asking to calculate the third root of 64. So it's the same process we're going to do. We're just going to add a little bit of a different last step here. So we want to break 64 into its prime factors. So we can say 64 is the same thing as 4 times 16, which 16 we can break down into 4 times 4. And I'm actually going to go ahead and stop right here just because I've noticed these 3 4s. So 64 has the factors of 3 4s inside of it, and our third root, unlike square roots now that ask for a number times itself, third roots ask for a number times itself 3 times. So we can see we have these 3 4s. 4 times 4 times 4 is equivalent to 64, making the third root of 64 simply 4. Because we get those 4 times 4 times 4 to get our third root here. So this one's nice and easy. This one reduces right down to 4. Letter B is asking us for a fourth root. So now this time we're looking for a number times itself 4 times to get 16. So let's go ahead and break 16 down and see if we can see any numbers that pop up 4 times. So 16 is equal to 4 times 4, which each of these 4s can be broken down into 2 2s. And luckily enough, we've got our 4 2s here, which is going to make the fourth root of 16 equal to 2. That's because we have 2 times itself 4 times. All right, now let's try some variable examples here. So let's break down 162 into some factors now. So 162, we're going to get 2 and 81. 81 is equal to 9 times 9, and both of these 9s become 3s. All right, so we can see our 162, we have a perfect fourth root of our 4 3s here. So we can say 81 has a fourth root of 3. So we can immediately pull out our 3 out front, and we're going to leave that 2 inside. But now let's address our variable terms here. So we know x to the 5th is equivalent to x times x times x times x times x, 5 x's. 4 of these x's will give us x to the 4th, which is a number times itself 4 times. So by definition, the fourth root of x to the 4th is simply just x. So we can pull out one of these x's, and we're going to leave the remaining x underneath our fourth root sign now. And our y to the 3rd, well, that's 3 y's, so we're just one shy of getting a fourth root there that works out. So we're going to end up leaving that y to the 3rd under our fourth root sign. So now let's go ahead and see what we have left. We had 1, 2, we had 1x, and our y to the 3rd that we were not able to simplify out of our fourth root. All right, why don't you go ahead and pause the video and see if you can work through these other 5 examples, and then once you're ready, unpause and we'll go through them all together. All right, letter D, we've got a third root this time. So let's break our 8 down into 2 and 4. 4 becomes 2 and 2. So that gives us that 2 we can pull out to the front. And then we've got our single x, which we are unable to pull out. And then we have our y to the 8th power here. So y to the 8th power gives us 8 y's. And we can group them up into groups of 3 for our third root here, which means we can pull out a y times y, which y times y is going to equal y squared, and we're going to be left with the y squared, these other 2 y's inside. So we're actually going to pull out a y squared here, and then leave our other 2 remaining y's, our y squared inside. Another easy way to do that is to just take our original number 8 and then see how many times 3 goes into 8. So 3 goes into 8 2 times. It's going to give us our y squared, and then we have 2 left over, giving us our y left under our third root there. All right, now we've got our letter E here. We already know that the fourth root of 16 is 2. We went over that earlier, so let's pull that out up front. And now taking a look at our A, well, A is to the first power here, so we're unable to take that out if we have our fourth root. Then we've got our B, so we're seeing how many times we can make groups of 4 fit inside our B to the 10th. So we can have a B squared that we can pull out. And then we're going to be left with 2 left over after we take away 2 groups of 4 from our 10. So we'll be left with a B squared underneath our fourth root here. And likewise, we can say we can have one group of 4 C's inside of our C to the 5th. So we can pull out 1 C, and then we'll have 1 left over here. So we'll have a single C left under our fourth root. And then we've got 81. So we actually looked at 81 inside of our letter C, that we saw 81, the fourth root, is equivalent to 3 here. And we've got 2 more to go over. These time just 2 more square roots now. So 120, let's break that down. And we could say 120 is equivalent to 4 times 30. And then 4 becomes 2 and 2. 30 becomes 5 and 6. And 6 becomes 2 and 3. So we've got our one group of 2 2's there that we can pull out. And then we have an x to the 4th, which that's 2 groups of 2 right there. So we can pull out those 2 groups of x and say that's x squared. Then we have our y to the 3rd, which gives us one group of 2. And then we'll have 1 y left over. So everything left inside, we've got our 5, our 2, and our 3, which is going to give us 30 here. And then we have our one single y. So we get 30y underneath our square root sign. Last up, we've got 169, which is actually a perfect square. 169 is equal to 13 times 13, so the square root of 169 is just 13. All right, that wraps it up for this lesson. If you have any questions, feel free to message me on Schoology. If not, I'll see you in our next video lesson. Take care, everybody.